Yeah, this is 10-6 here. When we start shifting everything, this is kind of when the shift hits the fan. I don't know. Anyway, actually, a fan blade is a conic. It's elliptic. It's ellipsis. Anyway, so first thing we have to go about with this is that now we're going to have centers that all of our centers can be located at some H and K. So what is H and K stand for? Horizontal and vertical. Very good. It was horizontal, left and right, vertical, up and down. It was where your starting points were. Earlier, our H's and K's were always at 0, 0. Now we're going to have some shift thrown to them, some horizontal movement, some vertical movement, and then we go from there. We also still have this value of A. The value of A is still the same as it was before. The A values are still going to be the distance from the center to a vertex. Your B value is still going to be the distance from a center to a co-vertex. And what do you think the C value is? Yep. The distance from the center to the focus. This info never changes. It doesn't change from where we were at before. How you find the focus doesn't change, whether it's an a squared plus b squared or an a squared minus b squared. That doesn't change either. Okay. The p value, that was another one we had in there. Oh, let me write down the a squared, b squared real quick. When do you use a squared plus b squared for which shape? You're right. I'll give you that, but for hyperbolas, thank you. These are for your hyperbolas. And those are for your ellipses. All right. P. P was the distance from what to what, remember? It was vertex. It was vertex to focus. And then the opposite of P was vertex to directrix. Okay. Which means we got to look at a whole bunch of formulas. Yay! Grab your calculators. Like we've done before, I'm not going to make you guys memorize formulas. There are certain things you'll have to know, but these types of formulas I'm not really too worried about. Okay. So hit the button that says apps. When we hit apps, does everybody have a conics option? We had a couple people first hour that did not. No, it depends on if somebody got into the calculators and deleted a bunch of the apps. I just have to re-upload it. So go to your conics one, and I'm going to show you guys what everything means. First one's a circle. I'm just going to put them all on the smartboard here, and I'll come back. Ellipse. Work. Hyperbola. There's a very boring bowl. So when you're going through these things, one thing I want you guys to notice, in the circles, there's two equations. One of them I don't care about. Which one do you think I don't care about? The bottom one, the second one. This second one is another way of writing it. We're not going to worry about that format. I'm never going to ask you to go that format, okay? So notice how you have all those H's and K's. Horizontal and vertical shifts. H's go X's, K's go Y. All right? The A's and B's, all of those still look the same. The only thing that's going to be different is we're moving them around the axis. Okay? So what I want to do today is start by just writing equations. We'll write equations, and then we're going to adjust equations. I don't think we're going to even get around to graphing fully yet today. So it's just going to be a lot of equation stuff. All right? For example. And if you want, I sometimes will just make a copy of this page and just have it out. So if you guys want to just have that as the note piece, that's fine. That way you don't have to keep going back to the calculator and all that. You can just have this apart. Sometimes people think it's easier on paper. I'll get that for you tomorrow. No. Oh, that's the wrong one. Let's do this one. Let's write the equation of an ellipse. Today I'll tell you what it is. Later on, I won't tell you what it is. Just like, don't shake your head. You guys know, what do vertices always look at? Focus. So do you have to know that it's an ellipse? No, if you plot it, you'll see that they're looking at each other. If you plot it, it's going this way, you know it's a hyperbola, things like that. So today, though, I'll tell you, hey, knucklehead, here's an ellipse. We have an ellipse with foci at 3,5 and 3, -1, and vertices at 3, 6 and 3, -2. All right? What do you think I'm going to say to do first? Graph it. Plot it. Figure out the directions. I know we're not graphing fully, we're just getting a rough sketch so you know which way it's going. Which formula do we use? That kind of thing. Because what happens if I don't tell you that's an ellipse? I just tell you have foci and vertices. You have to plot it to see where it's going. I mean, unless you can. So let's see here. Foci at 3, 5. Okay, I can count this. One right there. And then at 3, -1. Sorry. Okay. What's that? Great minds think alike. Shut up. You can tell right now which way is this being stretched. Why? Yeah. This has got to be stretched up and down because the foci are vertical to one another. Right away, you can tell that this has to be stretched up and down because the foci are vertical. Okay? When I go to do vertices then, we're at 3 and 6, and 3 and -2. I know for certain that now that it has to be going vertically. So I look at my fancy schmancy calculator for which formula stretches vertically for an ellipse. Well, we know it's going to be x minus h quantity squared plus y minus k quantity squared equals 1. But if it's stretched vertically, underneath which part is the a squared? We're going to utilize that formula. But now we got to figure out where the center is. Now, we know that A is the distance from the center to the vertex. B is the center to the covertex. C is the center to the foci. And if I'm starting at one spot and I've got to go a C value vertically and a C value other vertically, I don't want to say anti-vertically because then it would be horizontal. But if I go up, then I'd have to go down, but I'm still going the same distance, aren't I? which means I got to figure out what's the halfway point. What's halfway between my foci? What's halfway between my vertices? The midpoint of a foci, the midpoint of a vertex, the midpoint of a covertex is always the center. And what's nice is this. It's got to be on that vertical line, doesn't it? Your x-coordinate has to be 3 for the center. We just got to figure out what the midpoint is. What's 5 plus negative 1? What's half of that? There it is. Your center is at 3, 2. Here's your h. Here's your k. Now, all you have to do is count the distance from your center to your vertex. We go up 1, 2, 3, 4. We go up 4, or you go down 4. So your A value is 4. I don't know what my B value is. I don't have a covertex, but I do have a C value, don't I? How far did I go from my C value? I went up 3, or I go down 3. So my C value is 3. Well, I got to figure out what the B is. So A squared is 16. C squared is 9. It's an ellipse. How do you find the B? Is it with an ellipse? Is it A squared plus B squared, or is it A squared minus B squared? Minus B squared. What's that? Distance from the center to the focus. The focus was given discounted. Okay. So 16 minus what is 9? 7. Your B squared is 7. That's B. Okay. I don't need to plot it. I just need to write the equation. I only need B squared. So I fill in the blanks now. X minus 3 quantity squared over 7 plus y minus 2 quantity squared over 16 is 1. You're taking the little bits of info and filling it in. All right? Yeah. Yeah, you could be your center is always going to be shared either vertically or horizontally with something. Since the foci and the vertices are all vertical, that means the center has to be on that same vertical line. We know that the x value has to be 3. If you did find the midpoint between those two, what's 3 plus 3? What's half of it? 3. Did I have to do that? Same idea. Okay. We're just finding the midpoint. The vertice, I'm sorry, the center is always located at the midpoint of, it's the same value for the midpoint of the vertex, the covertex, or the foci. You're going to get the same number. Doesn't matter which one you choose. Hit it. What's 5 plus negative 1? What's half of that? Unless it changed in the past 3 seconds since I said that. Yes, it's always the midpoint. Okay. Yeah. There might be some of yours too. I don't know. Hyperbola. Look, I'm being nice. Tell you it's a hyperbola. Hyperbola. With foci at 5, 2, 5, negative 6. And vertices at 5, 0, and 5, negative 4. We actually will graph diagonal hyperbolas when we talk about polynomials. Weeks. Seriously, a couple weeks. What's that? And it's not so much it's not a conic section at that point. It's a polynomial thing that happens depending upon degrees and everything. Anyway, back to the hyperbola. Gee, what do you think we should do to start? Hey, probably a good idea. Hey, look, foci are up and down. Which way do you think this is going? Up and down. Vertices are at 5, 0, and 5, -4. So it's doing this. Okay. What's the H and K going to be for your center? It's going to be your H and K is going to be at 5 and 2, negative. Forgot the negative. Remember, it's got to be the same x coordinate because they're all vertical. And I have to do is find the midpoint of one of the y values. If I add 2 and -6, I get -4. Half of it's -2. I add 0 and -4, I get -4. Half of it is 2. Okay. Vertical hyperbola. Hyperbola. I can't even say that. If I look at my fancy calculator, it tells me a vertical one has the y squared first. Okay. So now I have to figure out my a squared, my b squared, my c squared, and all that kind of junk. Get the rest of it. So if we have a center at 5, -2, the distance from the center to the vertex is 2. So your a value is 2, which means a squared is 4. Good job. B, working on it. C is center to focus. Well, center to focus was up 4, or it's down 4. Okay? So my C value is 4. C squared is 16. To find B squared with a hyperbola, what's between the a squared and the b squared for a hyperbola? Plus. So 4 plus what is 16? 12. Now I have to fill in the blanks. Your center is at 5 and -2. So what's 5? H. And then -2 is the K. This is the style that you will make a mistake. Your H and K is always written out HK. The formula that we're using K comes first. Your formula has K written first. Anytime you have the K value that comes first, please take a second to make sure you don't accidentally write y minus 5. Because K is -2. Yes, sir.
Is it a squared plus b squared?
Yes, sir.
And why is that?
4 plus what is 16?
Oh,
It's okay. We all make mistakes. Yes. Because which way is horizontal is x is, vertical is y. It's the dumbest thing in the world to remember, but you will never forget. All right. So you get your final answer is y plus 2 quantity squared over 4 minus x minus 5 quantity squared over 12 is 1. And it's like I said, it's if you do minus and negative 2, we just rewrite it as plus 2. If you wrote y minus negative 2, I wouldn't yell at you. I would just do plus plus on your paper and give you that big sad face. Okay. I wouldn't say she disappointed me. I would just give a sad face. Okay. All right. Now, I know that this is probably the most difficult one that we're going to do. But I have faith in you. So, it's a circle. So in a roundabout way, we need to know the formula. Thank you. If the center is located at 4, -1, what's your h and k? 4 and -1. And if your radius is 7, what's the value of r? 7. All right, so like I said, this is, I know you can do it. I got faith. All right, ready? X minus 4 quantity squared plus y plus 1 quantity squared equals 7 squared, which is? I have faith in you, though. We haven't done a parabola yet, have we? Thanks. Did you just roll your eyes at me? So here's a parabola with a vertex and a focus. So we got to figure out what direction this is opening so we know whether it's an x squared or a y squared parabola. And then we can figure out what the p-value is, figure out if it's left or right, up or down. I wonder what the easiest thing to do first is. Do I see a rough sketch all the time? Is that what this is? Yeah. Anyway, so if my vertex is at 3, -2, my focus is at 3, -4, what direction is this moving? Excuse me. Now, here, when you have the parabola, what's your h and k? It's the vertex. Okay. And what's weird is if you look at how they do it here. I'll bring this over to the other one. What's weird with the parabolas? Oh, anyway, I didn't want to bring over. When you have it moving downward, is that an x squared or a y squared parabola? x squared, because it's down like a frown. So your h and k for a parabola is always the vertex. Okay, the h and k for the parabola is always the vertex. Always, always, always. So here, what do we have to figure out? Yeah, the p-value, how far away is it? So how far is it from vertex to focus? 2, so our p-value is -2. We are at that, it's moved downwards, so it's got to be -2. Fill in the blanks. No, it's an X. It should have been a Y. Really, 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 really badly drawn in that. Okay? That's how you write equations. Hey, guess what? I know, right? Do you remember this thing called completing the square? Hey, guess what? You're gonna use it. So let me show you this real quick. I had the wrong one open. So this doesn't look like anything we just did, does it? So, ladies and gentlemen, then turn the page over and get another sheet of paper. Now, yes, this is it's a little ugly. Anyway, so I want you guys to think about when you have all of the formulas that we have. Everything that we have is written in terms of perfect squares. Everything we have is written in terms of junk squared. Junk squared over a fraction. Junk squared plus junk squared over fraction equals 1. So what happens is, to switch it from this form to get it into the graphable or the how do you identify parts out of it, you have to do a lot of completing the squares. So what we want to do with this problem is figure out what conic it is and how do we get it to this conic form, like one of the formulas that is on the calculator. So as you go through it, you see you have a -9x squared plus a 4y minus a 36x minus a 16y minus a 164 is 0. Well, that's all fine and dandy, but I have to figure out a way to create perfect squares. It means there's a lot of well, to complete the squares. So here's what we do. We're going to group together the x's and group together the y's and move the constant. Why do I put in those plus blanks? You guys remember? Not h and k. Remember the process to completing the square? We took half of b, we squared it, added to both sides. But before we did that, oh, you'll get it good now. All right, you'll get it now. Before we completed the square, there was one rule that always had to be met. The x squared or the y squared, the coefficient of the square term always has to be 1. So what we have to do, we have to factor out some GCFs. Here's what I mean. I got to divide this by some number that makes this first term 1. What do I divide it by? So I'm going to factor out the negative 9. When I do that, I get x squared plus 4x plus blank. Okay. What do I have to take out of the next one? 4. Factor out the 4. I have y squared minus 4y plus blank equals 164 plus, here's where it gets tricky. I took out a negative 9, which means I have to put back a negative 9 times something. Because what's happening here, when you go to complete the square, at this point here, you guys did what? You took half of b. What was half of 4? 2. And you dropped it into here, and you squared it, right? When you square 2, what do you get? A 4. Now, this negative 9, though, when we did this with quadratics, we were always setting things equal to 0. That constant didn't matter. Now it matters because there's numbers on the other side. So this negative 9 comes back here. So it's a distributive property, which means it's got to go back here. Whatever you factor out has to go back. Half of b, well, half of positive 4 is 2. Square it, you get 4. Add it to both sides. But oh, Zach. Whatever you take half, when you take half of b, this is my b value, that's 2. That drops here. When you square this number, it goes back to there. All right? So here we have, what's half of negative 4? Negative 2. So down here I get y minus 2. When I square it, what do I put back up? 4. So now on the right-hand side, actually numbers that are fairly clean. What's negative 9? Yes, ma'am. It is. It is. What's negative 9 times 4? All right, what's negative 36 plus 16? What's negative 20 plus 164? Huh. Now what do you have to do? We combined all of our. We completed the square. We completed the square here to get this, to get jump squared. The negative 9 just comes on to the right. Yep. Now what do we do? Now you divide everything by 144. Guys, this is. All right, so you got. Guys. So 4 and 144, they're both divisible by 2, right? All right, what's half of 4? What's half of 144? All right, what's half of 2? What's half of 72? Nine and 144. What's up? Yep. Nine times what ends in a 4? 6. So what do you think? 6 times 9 is 54. What's 16 times 9? Yep. But that doesn't look like anything we've done, is it? Exactly. Flip them.
So is this a hyperbola?
It's a hyperbola. Very good. It's a hyperbola with the y squared first, which means which way does it go? Up and down. Yo. This is the style that we're getting towards. This is where, guys, this is where completing the square is an important trick. Completing the square is an important trick, and it's, if your numbers in the denominator wind up getting to become way awful, it means you screwed something up. 9 times out of 10, you're going to get somewhat clean value. It's not impossible to get fractions for the denominators, and I'll show you guys what happens with those as we go along. They're very, very, very easy to work with. Okay? This is not meant to be horrible. It's just where we're heading. Okay? It's where we're heading. No, it's not. It's just we're just completing the square. Yep. We're just not there yet. Today all we're doing is this. Today all I want you to do is write equations. Tomorrow we will spend the day working more and more and more with completing the square. And then we'll take that next step as far as graphing them tomorrow as well. Okay? The idea here is I have the PDF already posted. I don't know if I wrote down the actual numbers. But looky. It was nice of them to tell you what you were doing. I won't be this nice. I'm just say, hey, here's your vertices, here's your foci, figure out what you have and go. Okay? Because that's how I roll. Yeah. They should be, I'll put the numbers on what page it was, but the PDF file's there on 10.6, just do those. Write out the equations. Tomorrow we'll do more of that complete the square style and go on from there. Good fun.